This is SpaceTime Series 27, Episode 128, for broadcast on the 23rd of October 2024. Coming up on SpaceTime, dating the Moon's oldest impact crater. Scientists recreate the sound of the Earth's magnetic polar flip. And the X-37B Space Shuttle undertakes a pioneering aero-braking maneuver. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists believe they've pinpointed the age of the massive South Pole-Aitken Basin, the largest and oldest known impact crater on the Moon, determining that it's over 4.32 billion years old. The Moon, like the Earth, has been bombarded by asteroids and comets since its formation 4.5 billion years ago, leaving behind a history of craters and basins. However, the exact timing and intensity of most of these events, including the more than 2,000-kilometre wide South Pole-Aitken Basin, have remained unclear until now. However, by analysing a lunar meteorite known as Northwest Africa 2995, scientists have concluded that the Moon's oldest confirmed impact site is around 120 million years earlier than what's believed to be the most intense period of impact bombardment on the Moon. The new findings, reported in the journal Nature Astronomy, provide a far clearer picture of the Moon's early impact history. One of the study's authors, Joshua Snape from the University of Manchester, says scientists have been studying rocks collected during the Apollo, Lunar and Chang'e 5 missions, as well as lunar meteorites that have reached the Earth, slowly building up a picture of when these impact events occurred. For several decades, there's been general agreement that the most intense impact period, known as the Late Heavy Bombardment, was concentrated between 4.2 and 3.8 billion years ago, during the first half-billion years of the Moon's history. But now, constraining the age of the South Pole-Aitken Basin to 120 million years earlier weakens that argument for this narrow period of impact bombardment on the Moon, and instead indicates there was a far more gradual process of impacts over a longer period. The Northwest Africa 2995 meteorite was found in Algeria in 2005. It's what geologists refer to as regolith breccia, which means it contains fragments of different rock types that were once lunar soil and which were fused together by the heat and pressure involved in an impact event. During this event, they were flung off the Moon's surface as ejected debris, eventually making their way to Earth. By analysing the amount of uranium and lead found in a range of minerals and rock fragments from this meteorite, the authors were able to determine the materials date back to between 4.32 and 4.33 billion years ago. The team then compared the results to data collected by NASA's Lunar Prospector mission, which orbited the Moon studying its surface composition in 1998 and 1999. This comparison revealed many chemical similarities between the meteorite and the rocks within the South Pole-Aitken Basin, confirming their link and enabling the new age estimate. Now, these new findings also have implications reaching far beyond the Moon. We know both the Earth and the Moon experienced similar impact events during their early history. Problem is, most of the early rock records on Earth have been lost through a combination of erosion and plate tectonics. So, scientists can use what they learned about the Moon to provide clues about the conditions on Earth during the same period. Of course, the proposed 4.32 billion-year-old age of the South Pole-Aitken Basin now needs to be tested by a new sample return mission, collecting rocks from known localities within the crater itself. And that will be one of the prime tasks of the Artemis 3 mission, slated for launch to the lunar surface in 2026. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, scientists recreate what they think could be the sound of Earth's magnetic polar flip, and the X-37B Space Shuttle undertakes a pioneering aero-braking maneuver. All that and more still to come on SpaceTime. With growing evidence that the Earth's magnetic poles are about to flip, scientists have recreated the sound of an Earth magnetic flip. The Earth's magnetic field is vital for life on our planet. It acts like a shield, protecting us from the worst effects of the solar wind and intergalactic cosmic rays. These polarity reversals occur roughly every 250,000 years. However, the last flip was some 770,000 years ago, so we're well and truly overdue for the next. And when it does happen, it'll be the first magnetic field polarity reversal in modern times. And that raises some serious questions about how our technology will cope with the change. The Earth's magnetic field seems steady and true. It's reliable enough to navigate by. Yet largely hidden from daily life, the magnetic field actually drifts, waxes and wanes quite considerably. In fact, the magnetic North Pole's currently careering towards Siberia, which recently forced the global positioning system that underlies modern navigation to upgrade its software sooner than expected in order to account for the shift. But every roughly 250,000 years or so, the magnetic field dramatically shifts and reverses its polarity completely. In other words, the magnetic North Pole will shift to the geographic South Pole, and the magnetic South Pole will shift to the geographic North. The reversals have happened countless times over Earth's history, but scientists really only have a limited understanding of why the field reverses and exactly how it happens. We know that Earth's magnetic field is produced by the planet's molten liquid outer core as it spins around the solid iron inner core, generating powerful geomagnetic currents through what's called a Geodynamo-effect. This geodynamo creates a magnetic field that's mostly stable, going through roughly the geographic North and South poles. But the field shifts and weakens significantly during pole reversals. Now we know this happens because as new rocks form, typically either as volcanic lava flows or sediments being deposited on the seafloor, they record the magnetic field at the time they were created. So, geologists can survey this geological record and piece together the history of magnetic fields going back millions of years. But approximately 41,000 years ago, the Earth's magnetic field briefly reversed during what's known as the last champ event. During this time, the Earth's magnetic field weakened significantly, dropping to a minimum of just 5% its current strength. That allowed more cosmic rays to reach the planet's surface. Now, scientists from the Technical University of Denmark and the German Research Centre have used data from the European Space Agency Swarm spacecraft to recreate a sounded visualization of that event. The data from ESA's Swarm constellation is used to better understand how Earth's magnetic field's generated. The satellites measure magnetic signals not only from the core, but also from the mantle, the crust, the oceans, and up out into the ionosphere and magnetosphere. These data are crucial for studying phenomena such as geomagnetic reversals and the Earth's internal dynamics. And scientists use that to generate this stereo sound version. The soundscape was actually made using recordings of natural noises like wood creaking and rocks falling apart, blending them into familiar and strange, almost alien-like sounds. The process of transforming the sounds with data is similar to composing music for a score, and it provides a fascinating audio insight. Now, as to planet Earth's next magnetic pole reversal, scientists believe they may be seeing the early signs of a significant change in the planet's magnetic field now. Right now, there are regions of the Earth, including parts of the South Atlantic Ocean, where compass needles simply go nuts, pointing south instead of north. This region, known as the South-atlantic-anomaly, causes Earth's inner Van Allen radiation belt to move to its closest position towards the Earth's surface, dipping down to an altitude of just 200 kilometres. This results in an increased flux of energetic particles in this region, which exposes orbiting satellites to higher than usual levels of radiation. Now, since its initial discovery in 1958, the southern limits of the South-Atlantic-anomaly have remained roughly consistent. However, a long-term expansion has been measured to the northwest, the north, the northeast, and the east. As the geomagnetic field continues to weaken, the inner Van Allen belt gets closer to the Earth, with a commensurate enlargement of the South-Atlantic-anomaly at given altitudes. And it's not just an interesting quirk of nature. The South-atlantic-anomaly is of great significance to astronomical satellites and other spacecraft that orbit the planet at several hundred kilometres in altitude. These orbits take satellites through the anomaly periodically, exposing them to several minutes of strong radiation caused by the trapped protons in the inner Van Allen belt. NASA has also reported that laptops have crashed when spacecraft pass through the anomaly. The International Space Station, which orbits at an inclination of 51.6 degrees, requires additional shielding to deal with this problem. And the Hubble Space Telescope does not take observations while passing through the anomaly. And astronauts are also affected by this region. They see what can be best described as shooting stars in their visual field. The effect's actually caused by cosmic rays and other charged particles passing through their eyeballs. As far as we know, they don't do much damage, but for the astronaut, they appear as a sudden flash of light in their visual field. This is space-time. Still to come, the X-37B space shuttle undertakes a pioneering aerobraking manoeuvre, and later in the science report, a new study has found that deaths tend to increase in the days immediately following an extreme rain event. All that and more still to come on Space-Time. The United States Space Force's X-37B space shuttle has just completed a novel aero-braking manoeuvre designed to adjust its orbital flight path around the Earth. The operation allowed the spacecraft to safely eject its service module components so as to avoid creating more space junk. This is the first time the X-37B's employed a dynamic aero-braking manoeuvre. Aero-braking involves using the drag of the Earth's upper atmosphere to alter the spacecraft's orbit while conserving fuel. Using this manoeuvre to eject the service module meant that instead of floating around in space for years as space junk, the module will quickly descend into the Earth's atmosphere where it will burn up. Following the manoeuvre, the X-37B returned to its ongoing experiments, which follow on from 6 previously successful and equally secretive missions. The winged spaceplane was launched on its current classified flight back on December the 28th last year. Now, officially, the US Space Force is saying the rocket plane's involved in radiation experiments and what they're calling space domain awareness technology testing. Now, we know that means it's performing the functions of an inspector satellite, flying close to other satellites to study them to see what they're up to. Following its launch, it was initially placed in a highly elliptical orbit, but that's been changed multiple times depending on what else it's doing. And that's the key to the X-37B's success. Being able to constantly change its orbit means anyone tracking it won't know exactly where it is once it comes back from its apogee or most distant orbital position. It means that every time it reaches orbital perigee, those trying to track it to see what it's up to need to search the entire celestial sphere to try and find it again. Originally developed by NASA and Boeing in 1999, the X-37, as it was then called, was designed to be launched from the payload bay of the Space Shuttle. However, the program was taken over by the US Air Force in 2004, and 2 modified versions of the original X-37 were built. They were then transferred to the newly formed US Space Force in 2010. This is Space-Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that deaths tend to increase in the days immediately after an extreme rain event. The findings, reported in the British Medical Journal, are based on a study of death and rainfall data across 34 countries. Scientists looked at extreme rainfall that would usually occur only once or twice every year, once every 2 years, and once every 5 years. They found that in the 2 weeks after a 1 in 5 year event, deaths from any cause increased by 8%, heart-related deaths increased by 5%, and respiratory deaths by 29%. Only respiratory deaths increased after a 1 in 2 year event, and there was no change for 1 year events. The authors speculate there could be various reasons why this is happening, including reduced access to healthcare, increased airborne, water and foodborne disease risks from increased humidity, and increased anxiety. In fact, we could be seeing this in the increase in asthma-related cases during thunderstorms recorded in Victoria. As climate change sees extreme rainfall events increase, the authors say we should be aware of the potential flow-on effects. A major review of data from 9 studies has taken a close look at health effects from Mediterranean-style diets on young people. Scientists reanalyzed data on 557 people aged between 3 and 18, focusing on the benefits of sticking to a Mediterranean-style diet for heart health and cholesterol levels. A report in the Journal of the American Medical Association confirmed that a Mediterranean diet high in vegetables and olive oil and low in red and processed meats was linked to lower blood pressure and lower levels of low-density lipoproteins, the so-called bad cholesterol, as well as increased levels of high-density lipoproteins or good cholesterol. The authors say that introducing kids to a Mediterranean-style diet could help improve their health and set them up for healthy adult lives. Engineers have invented new energy-efficient bricks using scrap materials including glass that are normally destined for landfill. RMIT University engineers collaborated with Visy, Australia's largest recycling company, to make bricks with a minimum of 15% waste glass and 20% combusted solid waste or ash as substitutes for clay. A report in the journal Construction and Building Materials claims that tests have shown that the use of these bricks in the construction of a single-storey building could reduce household energy bills by up to 5% compared to regular bricks due to their improved insulation. Replacing clay with waste materials in the brick production helped reduce the firing temperature by up to 20% compared to standard brick mixtures, thereby offering potential cost savings to manufacturers as well. Around 1.4 trillion bricks are used in construction projects globally each year. The problem is business as usual brick production produces harmful emissions, including carbon dioxide, sulfur dioxide and chlorine, and puts a serious strain on natural resources, especially clay. The authors showed that these new bricks have enhanced energy efficiency through improved thermal performance, and they met stringent structural durability and environmental sustainability standards. Now, as we reported last week, the consumer advocacy group Choice has discovered that car manufacturers are not only spying on you when you drive, recording everything you do, but most of them are passing that data on to government and law enforcement. The Choice investigation found that most of Australia's popular makes of car collect and share data ranging from fuel usage, how you accelerate, how you apply your brakes, how fast you take corners, and just about every other aspect of your driving, even where you're going. Worse still, some are also recording what you say in the car, who you're calling or who's calling you on the phone, the content of your smartphone, and even videoing what's going on in the car. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
There's a lot of concern. I mean, we've got the security cameras being spied upon. People are worried about how much data that cars are collecting. EVs are collecting all this data on you, but also Wi-Fi itself and just mobile phones.
And also your vacuum cleaner is spying on you too.
Yeah, well, I mean, anything that is connected to the internet, especially if it has a camera or a microphone, could in theory be hacked. And that's a concern of the modern world. I saw on X a post that said the next big pandemic might not be a medical virus, but a computer virus, because we're so connected to our technologies that if a computer virus comes and wipes everything out and takes it offline even for a few hours, let alone days or weeks, that's going to disrupt the modern world. And we did see a taste of what that was like with the CrowdStrike outage a few weeks ago, where computers running Windows were running this CrowdStrike software which had privileged access into the system, and there was some sort of glitch that fritzed the kernel inside of Windows, and then we had airlines that couldn't board people, you couldn't make payments through your card systems, supermarket payment terminals, and the machines were shut down. So modern security and the lack of it is a big problem. And Telstra, the biggest phone company in Australia, has a new announcement that because nearly $3 billion Australian was lost to scammers in 2023, they're looking at how this prospect of being targeted is driving many of us to change how we use our mobile phone. 86% of Australians who own a mobile or smartphone are concerned about cybercriminals targeting their information, and in the last 12 months, 1 in 5 or 18% of Aussies have spent less time browsing the internet on their phones, whilst almost a third of mobile users, equivalent to about 6 million Australians, are now using their phones almost exclusively for calls and texts. And this is also a concern when you realise that many people haven't updated their phones to the newest versions of iOS or Android. And many of the Android users, if they have a cheaper phone that hasn't been updated in 3 or 4 years, it's probably not getting the security updates anymore. So one of the things that Telstra is doing, and I'm sure we'll see similar moves from the other big telcos, because once one of them moves in this regard, a lot of them do too. Telstra is giving its customers who have the My Telstra app, which any Telstra customer can download for free. They're getting this device security essentials, which is powered by McAfee. And so it's got a Wi-Fi scanner. When you're at a cafe or an airport or on the go, it's able to scan public Wi-Fi networks for security threats and alerts you to potential risk before you browse. And of course, you should be using a VPN when you're on public Wi-Fi, but this app doesn't offer that. But you can get VPNs quite inexpensively. There's also a safe browsing feature. So this is where you will get alerts before accessing risky websites and links, because it's scanning those. And I mean, there's a security issue as well. Do you want some software scanning you? But then if you don't have it and you click on a link that's potentially dodgy, could somebody hack into your phone? Obviously, it's a possibility. And also there's a device check, which is a security scan that helps detect and protect your device against suspicious apps and potentially harmful software. Now, there are differences for Android and iPhone users. For Android users, the feature will scan your phone and other devices for viruses and malware. On iPhones, Apple controls the security, and they do already have some built-in security to catch a lot of the malware, but Telstra's device feature will still scan your device software and passcode setting to ensure it's up to date. So look, it's something that the phone companies are doing to try and more proactively protect their customers. And it's a bit like with the banks in the UK. If you lose money to scammer, the UK banks now have to reimburse you. In Australia, they don't. And I have seen a lot of song and dance from the banks in Australia saying that they're triple checking when you send money and doing this whenever they can so they don't have to be forced by the government to reimburse people who've been scammed. So if you've got a Telstra account and you've got the My Telstra app on your Android or iOS phone, you go into the app and you can turn on the new security feature there, and you can turn that off if you don't want it either.
That's Alex Zaharov-Reutt from techadvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.